Okay, welcome to another video. In this video, we're going to talk about the Cramer's rule. Um, in order to solve the system of linear equation with the three variables, we learn how to do that using the Gaussian elimination. The other method that we want to talk about today is called the Cramer's rule. Now, this Cramer's rule is a little bit different than the Gaussian eliminations in a way that uh, we are going to use something called the determinant. Okay, so I'm just going to write down. Okay. So this is another way that we can use to solve the systems of a linear equation with the three variables. I'm going to share my screen so you guys can see. Okay, there you go. Any system of a linear equation, let me write down the general way of writing it. So you got a1x plus b1y plus c1z equals to d1. And next we have a2x plus b2y and c2z equals to d2. So this is just the regular, the normal system of a linear equation with the different coefficients of each term there. Okay, and the d3. All right. So what we're doing here is that we're going to have to find something called the determinant. We're going to have to put them into something called the coefficient matrix. So coefficient matrix here is that we are not including the constant. In other words, that we're going to set up the matrix like Gaussian eliminations, but we're going to have only 3 columns rather than 4 columns. Okay. So the first thing that we're going to have to find is something called determinant of the system. I'm just going to write determinant of a system, and then we have if you look at the vertical line is going to be the way that you're going to have to understand we are finding determinant there. Okay. So if you go back to the, we don't want to do this on two variables here, but if I have determinant like A, B, C, D, like so, then the value is going to be something called determinant is a value that consists of this matrix here. So that's just going to be A times D minus B times C. And that's just going to be for the 2 by 2 matrix. Okay. Now, 3 by 3 is a little bit different here. So that's what we're going to talk about. The first thing that we have to know here is that we need to understand how to set up to find the determinant of each system that we have. So then I'll show you how to find the value. Okay, so now remember, this is going to be your determinant for 2 by 2. But we're going to have to use a different way for 3 by 3 to find a determinant for the 3 by 3 matrix. And then we are going to use that determinant to find the solutions. Okay, so there are two steps here. One is the first step is to find the determinant for system x, y, z. And then once you find the determinant, then you're going to use that determinant to find the actual solution there. So the process one, the step one is find the determinant. Okay, so find determinant. Okay, so the first one is going to be find the system determinant. So that's just going to be collecting coefficient of A, B, C. So here you got A1, B1, C1. Then we have A2, B2, and C2, and A3, B3, and the C3. And we're going to have to do the same thing for X, Y, and Z. So now the determinant for X, all you have to do here is that you have to replace, okay, the X column with the constant column. Okay, so I'm going to use that. So you got D1, D2, D3. Okay, and then the other two columns are going to be the same thing. So you got B1, B2, B3, and C1, C2, and C3. And we're going to do the similar thing for the finding determinant for Y. Okay, as we did for the X column. Now we're going to replace the Y column with a constant column. So that would be a D1, D2, and D3, and everything else stays the same. So you'll have A1, A2, A3, and C1, C2, and the C3. And finally, we're going to have determinant for Z. Okay, so determinant for Z. Again, we are going to replace the column, the Z column, with a constant column. So that would be C1, C2, and the C3. And the other two columns stays the same. Okay, so B1, B2, and a B3. All right. So once we set up, the determinant for the system X, Y, Z, and I'm going to show you how to find the determinant from this each one of them. But once we find that, the value, that solution for this one is going to be X is going to be equal to determinant X over D. And Y is going to be determinant of Y over D. And the Z is going to be determinant of Z divided by D. So determinant cannot be zero, because if it's zero, it's undefined. You can't really do this. And this is going to be how you're going to find the solution. Okay, so once you find the determinant, it's not really an answer. You're going to have to go down to this portion of it and plug that in to find the x, y, z value. In other words, that dx, dy, dz is not your answer. You're still going to have to divide that by determinant of the system. So how do we actually find this determinant for each one of them? There is the one way that we're going to do this is simply, okay. So the system is going to be, you have to use the rule here, okay. So what the rule here is that there's a couple of rules that we're going to have to follow, okay. So whatever the the rule that you're going to use, the sign convention is going to be this. I will tell you exactly what I'm talking about here in a minute. But so whatever that the column or row that you're going to use, you're going to have to follow this sign conventions, okay? And I'll show you what I mean by this, okay? So you're going to have to use the this sign convention. You cannot, change this or anything. If you are not going to follow this, then you're going to be end up with the wrong answer. Okay. Now you do have a choice. Okay, what we call the pivot rows or pivot columns. You can use any columns that you like. Okay. But our job here is to, whether you use the rows and columns, we are breaking this thing into the 2 by 2 matrix here. So for example, I am going to use the rows, first row, for example, as my pivot. Okay, then we're going to expand this. Okay, so if that's the case, then A1, B1, C1 is going to be your coefficient, like A1. Now then, this becomes a 2 by 2 matrix. Okay, so you're going to have to look at the first row, then look at the first column, and whatever remaining is going to be in the matrix here. So that would be B2, C2, B3, and the C3. Okay. You can, use the different convention here, but the easiest way here is that, if you select the row or column, that entry of that row or column becomes your coefficient of the matrix. So here's A1. So that's what I use over there. Okay, the first one there. Now then, after that, you are going to go through the each column or row. So here I chose the first row. Then I'm going to go through the first row, first column right here. Okay. So whatever the remaining after because the pivot row, you cannot use it. And then I'm going to, first, I'm going to use the first column. So whatever the remaining is going to be, it's going to be inside the matrix of 2 by 2. So you see that B2, C2, B3, and the C3. Okay? So because I'm using the first row, I have to follow the sign convention on up top here. So you got plus, minus, plus. So the next one is going to be minus, because the sign minus. Okay. Then I am going to now use the second column, right? So that means, okay, I have to, I don't know, right? Let me see if I can. Okay, now I am going to use the first row, the second column. So now the second column is going to get highlighted, and whatever is going to be remaining is going to be inside the next matrix. So here you got minus B1, then whatever the remaining is going to be A2, C2, and A3, and the C3. Okay, so the next column is going to be plus. So I'm going to use the plus over here. All right, now if I shade, now you're going to have to assume that if I can delete this. Oh, no. I don't think I can delete just the column. Oh, okay. So the next one that we are going to shade is going to be the last column, right? So the this column over here. And the remaining here is going to be A2, B2, and A3, B3. So here we have C1. Then you have A2, B2, I mean B3, sorry. B2, yeah, right. And A3, B3. Okay. And so once you set up the 2 by 2 matrix here, then you're just going to have to follow this method for 2 by 2 matrix up here, right? Over here. and find what the determinant is for each case. And we're going to do that for all, for the d of x, d of y, and d of z, or all the determinants. So the obvious thing here is that, if this is the case that we are going to find the determinant, then whatever the row and the column that contains the many zeros, then that's what I'm going to use. Because if you have a 0, it doesn't matter what you have inside the matrix, a 2x2 matrix, it's going to be 0 anyway. So it's going to be very, very simpler. So when I use the Cramer's rule, when I look at the systems of linear equations, then I'm always going to, once I set this up, okay, then I'm going to look for the rows or columns whichever contains the many zeros, and that's going to be my pivot row or pivot column. Okay. So I'm going to show you an example, and I'm going to go through slowly, and so you guys can see this. Okay. And the you may find this one easier, or some students may find this is a lot more difficult, but just look at this example and compare to the Gaussian eliminations. Okay. So now I have x minus 2y plus z equals to minus 9. I have minus 3x plus y, okay, and minus 2z, okay, equals to 5. And then I have a 4x, okay, and plus 3z, okay, equals to 1. All right, so the first thing we're going to have to do here is that we're going to have to set up the matrix. Okay, so the first you have to find the determinant. I forgot to write this thing down here. So number 2, and you find the solution. Okay, so that's the second step. So then in this example, we're going to set up the determinant of the system. I'm just going to call the D. I'm going to call the system. So this is just going to be simply the matrix of, we call this coefficient matrix because we're only going to have coefficients only for x, y, and z. So here we're just going to have 1, minus 2, 1. And then I have a minus 3, 1, minus 2. Then I have a 4, 0, and 3. So that's going to be my determinant of the system. Okay. Next one, I'm going to have determinant for x. Now remember the determinant of x, y, z, they are going to get replaced, those x columns, y column, and z column, by constant numbers here, right? So here, determinant for x, we're going to replace the 1, minus 3, and 4 with minus 9, 5, 1. So we're just going to place that here. And the remaining one is going to stays the same, minus 2, 1, 0, 1, minus 2, and 3. All right, so now next one, we're going to look at the determinant for y. Again, we're going to replace the y column with a constant column, but the other one's going to stays the same. And the minus 9, 5, and 1. Then 1, minus 2, and 3. Okay. And the last one, z column. So again, we're going to have last column going to get replaced by constant column, which is the minus 9, 5, and the 1. Okay. So we're going to have to find this determinant here. So I'm going to do first, I'm going to do the determinant for system. Okay. I'm going to rewrite this. So you got 1, minus 2, and 1. and minus 3, 1, minus 2, 4, 0, 3. So what I'm going to do here is I'm going to select a row or column that becomes my pivot row. Okay, so what I'm going to do is I'm going to use the third row as my pivot row. Okay, so we're going to expand this. Remember that these numbers in the location is just going to become your coefficient there. So first, remember that we're going to have to follow the sign convention there. So if you look at the sign convention, it's going to be first determinant plus, the next one is going to be minus, and the third one is going to be plus. So that's what we're going to have. So first one is going to be plus, so you got 4 times. Okay, that's positive. So because we are looking at the third row here, and we're going to have to go through the column this time. So then third row, first column. Okay. The remaining here is going to be minus 2, 1, and 1 and negative 2. Okay. Now, minus 0 times. Okay, so I'm going to use, even though we are not, we're going to multiply by 0, I still want to show you. So if I shade the second column over here, whatever the remaining is going to be, don't worry about this yellow shade. This is gone now. So the remaining here is going to be 1, 1, 1, 1, minus 3, and minus 2. But this becomes a 0 anyway, right? So we don't have to worry about them. Next one's going to be positive 3. Then I'm going to shade this with the purple. So now this column right here. So what the other two columns is not shaded by purple. It's going to be 1 minus 2 and minus 3 and 1. Okay. So we're going to have to calculate this before we move on. So remember that. So you got 4 times, and remember AD minus BC, right? So you got minus 2 times minus 2 minus 1 times 1. A times D minus B times C. So you got, this is going to be A. That's going to be B. That's the C, and that's the D. So A times D, that's what I did here, minus 2 times minus 2, minus B times C, you got 1 times 1. The second term over here, we don't care. That's going to be 0 anyway. So that's going to be 0. Then plus 3 times. So again, this is going to be A, B, C, D here. So we got 1 times 1 minus B times C. So you got minus 2 times minus 3. All right. So what we have here is going to be what? Minus 2 times minus 2, we get positive 4. 1 times 1, but you have to subtract that. Then plus 3 times, 1 times 1, you get 1. Here you got minus 2 times minus 3, you got positive 6, but you got minus in front of it, so you got minus 6 there. So here you got 4 times the 3 plus 3 times minus 5. So I have what? 12 minus 15. Okay, so that should be minus 3. So determinant of the system, I have minus 3. All right, so this becomes the denominator, right? All right, let's look at the now x determinant over here. So determinant of x. All right, so let's just rewrite what we have on the above. So you got minus 951 I'm just going to rewrite that here. Minus 9, 5, 1. And then we have what? Minus 2, 1, 0. Let me just write that. Minus 2, 1, 0. And then the z column is going to be 1 minus 2, 3. All right. So we're going to have to find out which is going to be my pivot. So I'm just going to use the same pivot that I used for the system. So that means I'm going to use a third row. Okay, so right here again. Okay, so the first one is going to be same sign convention, plus, minus, plus, right? So that's going to be 1 times. Okay, so that means the third row, first column. Okay, so I use the yellow here. So I'm going to shade this one. Remaining here is going to be minus 2, 1, and 1 minus 2. All right. Second one is going to be 0. Okay. And the if I use the green one here, down here, this one, then you have minus 9 and 1, and 5 and minus 2. It's not going to make any difference because of the 0. You're going to multiply 0, right? And then plus 3 times. So I'm going to shade it with the purple here. And the remaining one is going to be a minus 9, minus 2, 5, and 1. Okay. All right, let's use the determinant here. So you got 1 times, again, AD minus BC, same thing as what we did for the system. So minus 2 times minus 2, minus 1 times 1, minus 0, plus 3 times, you got minus 9 times 1, minus 2 times 5. Okay, so you got 1 times. So minus 2 times minus 2, we get positive 4. And 1 times 1, you get 1, but minus here, you got minus 1. And next one, you got minus 9 times 1, you get minus 9. Here you got minus 2 times 5, you got minus 10, but you got plus minus here, so minus gives you positive. So that should be a 10. Okay, so what we have here is going to be 4 minus 1 is a 3 times 3. 3 times 1, you get 3 here. Minus 9 times plus 10, you get 1. Positive 1 times 3, you get positive 3. We have 6. So d of x is going to be a 6. All right, let's look at the C. D of y. Now remember, now the y column becomes the constant column, right? Because that's what you see here. So 1 minus 3 and 4, that's the x column. 1 minus 3 and 4. Oh, let me use the red. Minus 9, 5 and 1, and 1 minus 2 and 3. Okay. Let's make sure. Okay. Now, unfortunately, for the y, we don't have any zeros. So in this case, we can use any pivots and rows or columns for our pivot. So I want to be consistent here. So I'm going to use the third row again. Okay, over here. Even though that's what I'm saying. If you don't have any zeros in your rows and columns, then choose anything that you like. But if there is at least one zeros on the rows and column, then you might want to choose that row or column to be your pivot row or pivot column. Okay. So here, the coefficient is going to be, remember that the third row, same thing, sign convention is going to be plus, minus, plus. Okay. So here we go. Oops, sorry. So the 4, okay. So that means the first column over here. And the remaining here is going to be minus 9 and 1 and 5 and minus 2. Second is going to be the minus times 1. Okay, we're just going to have to do another calculation in the middle there. So on the middle one, let me just get the green one over here. So the remaining here is going to be 1, 1, minus 3, and minus 2. And the last one is going to be plus 3 times. Okay. So I'm going to use the purple one. See if I get them out. So the remaining is going to be 1 minus 9, minus 3 and 5. Now, when I say remaining, we do not count the pivot row, and we do not count the column or row that you are selecting. So, for example, the last one I just did, pivot row was a third row, so none of this is going to go in there. And I select the third column, so they cannot go in there. So whatever remaining is going to be go inside that determinant matrix there. So in this case, 1 minus 9, minus 3 and 5. Okay. So now we're going to have to use the 2 by 2 matrix way to calculate this. So let's do this. I have a minus 9 times minus 2 minus 1 times 5 minus 1 times, you got 1 times minus 2 minus 1 times minus 3. Okay, and the plus 3 times, okay, 1 times 5 minus minus 9. Let me just move this a little bit here. Minus 9 times minus 3. Okay. As you can see, we are doing one more calculation in the middle, right? The other one, the reason that the other two that we didn't have to do that was because we had a 0 in front of it. Because we didn't, it doesn't make any sense. If you multiply anything by 0, you're not going to get anything, right? All right, so let's just finish this. So minus 2 times minus 9 times minus 2, we get 18. Minus 1 times 5, you get minus 5. Okay, and minus 1 times minus 2, I get minus 2. 1 times minus 3 is a negative 3, but we have a minus in front of it, so that's going to be plus 3. The last one, you got 3. 1 times 5, you got 5. Minus 9 times minus 3, you get what? Positive 27, but you got minus in front of it, so you got minus 27. Okay. So I have a 4 times 18 minus 5, that's 13. Minus, you got minus 2 plus 3, I got positive 1. Plus 3 times, you got 5 minus 27, I have a minus 22. Okay, so 4 times 13, that's 42. Minus 1, minus 66. Okay. So 42 minus 1 minus 67. So I'm just going 42 minus 67. So that's going to be minus 15. Right? All right, so we found the determinant for y, so that's good. Even though we had to do all three calculations, it come out to be pretty good. Now let's look at the d. So that's going to be determinant find the z. So the z column is going to get replaced. Okay, so you got 1, minus 3, and 4. What was the second column? Minus 2, 1, 0. I'm just going to put that here. Minus 2, 1, 0. And the last one is going to be the constant column. So in this case, minus 9, okay, and 5, 1. Okay. So just like the other, when we found the determinant for the system and x, we are, obviously we have zeros in the third row or the second column. So I'm just going to be consistent and I'm going to use the third row again. Okay, so this row here. Now that means you get 4 times. So we're going to have to block the first column right here, and whatever is remaining, not shaded area, is going to be minus 2, minus 9, 1, and 5. Then you got minus 0. Okay. And we are going to use the green color. So the remaining here is going to be 1 minus 9 and minus 3 and 5. It doesn't matter because it's going to be multiplied by 0. And the last column, we're going to have 1. And let me use the purple over here. And the remaining here is going to be a 1, minus 2, minus 3, and 1. Okay. Okay, so let's use the 2x2 matrix, finding the value here. So you got A times D, that would be minus 2 times 5 minus minus 9 times 1 minus 0 plus 1 times 1 minus 2 times minus 3. All right. So inside you got minus 2 times 5, that's negative 10. Minus 9 times 1, you get minus 9, but we have a minus in front of it, so you get positive 9. That's going to be 0 plus 1 times. So 1 times 1, you get 1. You got minus 2 times minus 3, you get positive 6, but you got minus in front of it, so you got minus 6 there. So that means we got 4 times minus 1 plus minus 5. Okay. So I have a minus 4 minus 5. So that would be minus 9. Okay. So we have finished, right? Finding determinant for x, y, z, and the system. So let me just rewrite what we found here. So I have a determinant for system, and we found that to be -3. Okay, so determinant of a system is going to be -3. Determinant for x, okay, we found that to be 6. And determinant for y, we found that to be a -15. And determinant of z is going to be -9. All right, so now we're going to have to find the x, y, z value here, right? So here x equals to d over x over d over system. So d over x is going to be 6, and the d over system is going to be -3. So the x here is -2. Now y is going to be the determinant for y over determinant for system. And determinant y was -15, and determinant of a system is going to be -3. So the y is 5. Okay. And the z is the determinant of a z divided by determinant of a system. So determinant of a z is -9. And determinant of the system is going to be -3. So that becomes a 3. Okay. So the solution for, okay, for this system of a linear equation is going to be -2, 5, and 3. Okay. So if you go back and look through what we did here is the bulk of work is going to be done trying to find out what the determinant is for system x and y and z. So the couple of things that we have to remember is that you're going to have to set up the determinant correctly. That's going to be the first thing. I'm just going to write this, highlight this one here. So the first, you're going to have to set up your determinant correctly. Okay, so collecting all the coefficients from the system of a linear equation and put them into the correct determinant form like this. So once you put them into the determinant form, now you're going to have to find the determinant for each system, x, y, and z. Okay, and except the system, finding determinant x, y, z, you have to replace the constant column with the determinant of the variable that you are finding. So if you are finding determinant for x, then you're going to replace that x column with a constant column. For y, you replace the y column with the constant column, and the z, you want to replace that with the constant column. So once you have done that, except the system, you don't have to replace anything. Just use the x, y, z column there. And then you're going to have to determine which row or column that you are going to use as your pivot. It depends on the columns or rows that you are going to use. The sign convention of the matrix, that 2 by 2 matrix you're going to come up with, is going to be different, right? So make sure that you follow this, the sign conventions, so you're not going to make any mistake here. Okay. So once you determine, which row or column that you're going to use as a pivot, the recommendation here is that choose the rows and or columns that contains many zeros. Okay. The reason is that if you contain the zero and you use that as your pivot, that means that you don't really need to calculate the location that contains a zero, because a zero times anything is going to be zero anyway, right? So once you select your row or column as your pivot, you are going to go through the each column or each row, and then select the entries for your 2 by 2 matrix. Okay, and that's what we did when we go through the finding determinant as the for x, y, and z variable. So once you determine your pivot row, then if it's going to be row, then you're going to have to go through the column 1, then column 2, and column 3. As you go through each column, you're going to select the remaining entries and put them into the 2 by 2 matrix for that column. If it's going to be, if you are using as a column as your pivot row, then you're going to have to go through row 1, row 2, and row 3. And every time you select a row for your pivot column, then the remaining entry will be going to the your 2 by 2 matrix there. So once you go through that, you're going to find the determinant for x system and x, y, z. And the to find the solution is going to be just dividing the dx, dy, and dz, and divide by the determinant of the system. Okay, now remember this system cannot be zero, and that's going to be the problem for Cramer's rule. So somehow that you found that determinant system is going to be equal to zero, then you cannot use the Cramer's rule. Okay, so that's the one thing that we're going to have to look at. Now, we don't have any that type of restrictions on the Gaussian eliminations, okay? But the Cramer's rule, okay, the system cannot be equal to zero. But there will be the problems that you will have that d of a system is equal to zero. Okay, so that means that you cannot apply the Cramer's rule, so you're gonna have to go back to the Gaussian elimination to solve that system of linear equations. So that's the one of the conditions that you have in the Cramer's rule. So if you don't want to, take care of that stuff, then you can just go back and Gaussian elimination, and then find the z value, then start doing the back substitutions. Okay, but like I said, this is another method that you can use to solve the system of linear equations. Okay, so you will have opportunity to demonstrate the both Cramer's rule and the Gaussian eliminations in the next take-home exam. Okay, so I am going to provide you with the whiteboard link. So if you don't want to watch this, you don't want to hear my voice, you just want to access the my whiteboard here, then you're just going to have to install the whiteboard, and you should be able to access the whiteboard. Okay, I don't think you can make any changes though, but you can still go through what I did. Okay, you can kind of move around. You should be able to do that, but I don't think you can change anything what I just wrote it up here. I'm not sure. I haven't tried that one, so let me know what you guys have here. So I will give you that link as well as the recording here. if you just want to look at the whiteboard and what I did, then so you don't have to watch all the about 1 hour recording. That's fine. Okay, you can just access the whiteboard. I'll give you the link so you guys can have access to this Microsoft whiteboard here. The other thing that I want to talk to you about is the systems of linear inequalities. So let me just talk about that, okay, before I finish this. So the next thing that we want to look at, this is just going to be the two variable. Okay, so here we have a system of linear inequalities. So if you look, just like the systems of linear equations, linear inequality works the same way. But what I want to do here is that the difference between the system of linear equation and linear inequalities is that system of linear inequalities, you have many solutions if you have one, or in the equation you just have one, right? If you cross one another, that's going to be a solution. But systems of linear inequalities, we have many different areas of a solution. So you're going to have to shade the graph to tell me which one it is. Okay, so this is not that bad. You're just going to have to learn how to draw the line. Okay, a couple of things I'm going to tell you when you draw the graph. Now, if you have less than equal to or greater than equal to, this must be solid line. Okay, when you draw the graph on the graphing paper, if it's going to be greater than or lesser, and this has to be a dotted line. Okay, so if you use the wrong line, then your points will be deducted. So be careful. All right. So a solid line is going to be greater than equal to or less than equal to. Greater or lesser, you have to use a dotted line here. So let me show you what I mean by that. So here's the example. I have a 3x plus y is less than equal to 7. Then I have 4x minus 2y is less than equal to 8. So the first thing that we have to do here is that we're going to have to draw a graph on the line. So I'm just going to draw the xy graph over here. Then we're going to come back and draw the line here. So let's just look at the 3x plus y. I'm going to make it equation for a minute. Then I'm going to find the x-intercept. Then I'm going to find the y-intercept so I can draw the line. So x-intercept means y equals to 0, right? So let's plug in y equal to 0 up there. So that means 3x plus 0 equals to 7. So x has to be 7 over 3. So that means we have, okay, so 7, a little bit, 7 over 3 and the 0. Well, y-intercept means the x equal to 0. So plug in x equal to 0 here. So you got 3 times the 0 plus y equals to 7. So that means y equals to 7. So I have a 0 and a 7 here. So that's going to be our 2 points that we need to draw the line here. So first one is about little over 2, right? So I would say, the x-intercept is going to be around 2 point something, I would say. 2.5. So I would say over here. Okay, so that's going to be 7/3 and the 0. The other one is the y-intercept is going to be 7. So that's going to be way up here. So 0 and 7 here. Now, since we have less than equal to 7, less than equal to means a solid line, right? So I'm going to use the green one. Okay. So this green line over here is representing 3x plus y equals to 7. Okay. All right, the next line that we're going to have to draw is 4x minus 2y. Let me just do over here. I have a 4x minus 2y equals to 8. So again, we're going to use the x and y intercept here. So x-intercept, y equal to 0. So let's plug that in. So 4x minus 2 times 0 equals to 8. So that comes out to be x equals to 2. So the x-intercept is going to be 2, 0. Now we're going to look at the y-intercept. So y-intercept means the x equal to 0. So plug in x equal to 0, 4 times 0, minus 2y equals to 8. So now y becomes minus 4. So that would be a 0 and minus 4. Okay? All right. So we are going to draw this. And let's just plot this for. So when x equals to 2, that's going to be about here. Okay, and the other one is going to be 4, negative 4. Let me put that over here. So you have a 0 and negative 4. That's this point here. And that point is going to be 2 and 0. Okay, so I'm going to use the blue. Okay, so let me just use the blue here. Oh. Okay, so this blue line represents 4x minus 2y equals to 8. All right. Okay, so now we need to find out the solution area here. Okay, so let's look at the first inequality. So 3x plus y is less than equal to 7. So let me just use the red this time. So you got 3x plus y is less than equal to 7. So we are looking at the this green line. So we want to find out the which side is going to be our solution for the green line. So I'm going to use the 0, 0. If it may, and I plug that into the inequality. If it makes sense, then we're going to shade that area. If it doesn't make any sense, then we're going to shade the other side. Okay, so we're going to use the 0, 0 for both of them. Okay, so that's the 0, 0. Okay, so I'm going to plug that in. I'm going to put 0, 0 here, origin. Okay. So if I plug in x equal to 0 and y equal to 0, that's what we'll plug it in here. Maybe I should use the green, right? So let me just do that because that's what the green was. So we're going to use the 0, 0 for 3x plus y is going to be less than equal to 7. So let's plug that in if it's true. So plug that in there. Now, is this going to be less than 7? So that's going to be 0 is less than equal to 7. That's true. Okay. So we are going to shade the area of 0, 0. Okay, so that's going to be area here. Okay. Now, what about the other one? Okay, so now we have 4x. We're still going to use the 0, 0. Now, you don't want to use the 0, 0 if one of these lines is going to cross that 0, 0. Okay, you have to use the other one. So now we have what? 4x minus 2y is going to be less than equal to 8. We're still going to try 0, 0. So if the 0, 0 makes sense, we're going to shade that side. If it doesn't make any sense, we're going to shade the other side over here. Let's plug that in. So you got 4 times 0 minus 2 times 0. Is this going to be less than equal to 8? Well, that's going to be 0, right? 0 is indeed less than equal to 8. So that's also true. So that means we're going to shade the area that contains a 0 and 0, right? So I'm just going to extend this a little bit over here. And then we're going to now okay. So wherever the these two, the green line, line and the blue line, intersects, those going to be our solutions. So the solution, you can say all this come down here. Okay, all this is going to be our solutions. Okay. I'm just going to show you a little bit over here. Yeah. Okay, so you cannot include the this area here. You cannot include over there, but all the other areas is going to be fine. So that should be our solution region. Okay, so that will be a solution region. Okay, again, the same thing applies for the inequalities. If you have two parallel lines, then neither of these shaded area intersect. That means there is no solution. Okay. If this would have been like less than 7, less than 8, then these blue lines and green lines should have been dotted line. Okay, instead of a solid. Okay, so just want to make sure that you guys don't make any mistakes on the using the proper line there. Okay. So what I have here is that we talked about the Cramer's rule and the system of linear equalities for two variable. Okay, so I'm going to ask you to watch this recording, and also you have access to the this whiteboard. I'm going to give you that access so you guys can access this. I know that some of you don't want to watch this, so but you're still gonna have to watch it though, okay? Because of attendance. All right, so I am going to stop here. Then the next time that which is gonna be what, Monday, we're going to go to the chapter 8. So that's going to be the functions. Then we're going to talk about the exponential functions and the logarithmic functions. So we will spend the next Monday and Wednesday on chapter 8 before you come to class on the Monday, November 30th. Okay? All right. Thanks for coming. Okay? Be sure to watch this recording. Okay? And if you, like I said, if you want to look at the just the lecture part, in addition to the recording, I will have the link for the accessing the whiteboard. Okay, so you guys can have access to the whiteboard as well. All right, thanks. Okay, I'll see you guys later. Okay, bye bye.